Oh, I guess it's recording, guys. I just wanted to say what up. Thanks for doing the homework. If you have any questions, hopefully these answer your questions. It's on YouTube, so you guys can just forward to the questions that you guys need answers. If you miss my face, hi, what up? Okay, so. Alright, so what are the inverse functions of function below? Use function notation. Okay, so we learned in the video that to write an inverse function, you need to switch x and y. So you first rewrite this as y equals 3x minus 6, and then you want to switch x and y, so you get x equals 3y minus 6. And then you want to just isolate y. So you add 6. You get x plus 6 equals 3y. Then divide by 3, and you get y equals 1/3 x. So x divided by 3 is same thing as 1/3 x. And then 6 divided by 3 is 2. So there's our inverse function. And then to use a proper notation, f inverse is equal to 1/3 x plus 2. Okay, and then here g of x, so we're going to rewrite it, y equals x cubed minus 5, switch x and y, and then solve for y. So you need to add 5, and then to undo the cubing of y, you need to cube root both sides. So then you get y equals the cube root. Right, the cube root undoes that, and so that's why you just get y, and then you get the cube root of x plus 5. So then using inverse notation, since our function was called g inverse is the cube root of x plus 5. And then here, again, rewrite it, y equals 2x plus 3 cubed. And then you want to switch x and y. And then solve for y. So again, you want to work basically using order of operations. So remember, you want to undo this first. So then you basically have 1/2 x, divide everything by 2, equals y plus 3 cubed, and then you cube root both sides to get rid of the uncubed. Hold on, this is so annoying. My dog is trying to get out of my room. She's scratching at the door. Okay, and now I'm just talking to myself basically. Hopefully I cut that out of the video. Alright, so then to undo the cube, you cube root both sides, so you have 1/2 x cube root. That undoes the cube, and then you get cube root 1/2 x equals y plus 3. So one last thing we need to do to isolate y, you need to subtract 3. So you get y equals a cube root of 1/2 x minus 3. And then write it with function notation. So our function was named f, or clearly that's not an f, p. So p inverse of x equals 1/2 x minus 3. I guess I should write that for the other ones here. cut that out as well. Okay. So here we got t of x. So again, rewrite it as y, 10x minus 4, 3. Switch x and y. Solve. Oops. That's not very pretty. Okay, and then you get rid of the dividing by 3 by multiplying everything by 3. And then you get 10y minus 4. Now I know you're probably going to want to distribute, but that's actually not the best idea, right? You want to divide by 10 first. You know, your first thing is like, oh, I want to distribute that, but you don't want to do that. You need to get rid of this 10, right? You need to, like, right now the y is trapped in this parentheses, so you got to untrap it. So you can get 3 tenths x equals y minus 4. So you divide both sides by 10, and that goes away, and then you just get the y minus 4, and then you add 4 to both sides. So now y is isolated. So again, our function was t, so now we write not f. T inverse of x equals 3 tenths x plus 4. Okay, so next problem. It says make a table of y equals 1/2 x minus 3 and its inverse function. Okay, so the x values are already here, so you just plug it in. So you plug in like 1/2, you plug in 1/2 x minus 3, right? So 1/2, let me zoom in a little, 1/2 times negative 4 minus 3, right? That gives you negative 2 minus 3, which is negative 5. Then you got 1/2 negative 2 minus 3. 1/2 of negative 2 is negative 1. Negative 1 minus 3 is negative 4. And then so on. So 1/2 of 0 is 0, minus 3 is minus 3, and then 1/2 of 2 is 1, minus 3 is negative 2, and 1/2 of 4 is 2, minus 3 is negative 1. Okay, and then the inverse function, remember what we said, those values just switch. So then this is negative 5, negative 4, negative 3, negative 2, negative 1, and our y's are now negative 4, negative 2, 0, 2, 4. Right, so whatever these x values are, right, now there are y values, and whatever our y values are, then those are x values. So what's the relationship between the table for the inverse and the function and its inverse, right? The inputs and outputs switch. Okay, so graph y equals 1/2 x minus 3 and its inverse on the same set of axes. Okay, so I remember our negative 3 here. This is our y-intercept, so we plot that here. Then slope of 1/2, right? You go up 1 over 2. You plot those points. And like these points should be the same points on our table. Like, look, negative 4, negative 5, negative 4, negative 5, that's here. Negative 2, negative 4, right? That's here. 0, negative 3, 2, negative 2, 4, negative 1. Right, and then that one is on our graph, but not on our table. But, okay, and then you want to use your trusty ruler. So this is y equals 1/2 x minus 3. Okay, and then our inverse function, we just have the points. So let's just go ahead and plot those. Negative 5, negative 4, that's here. Negative 4, negative 2, that's here. Negative 3, 0, it's here. Negative 2, 2 is here. negative 1, 4 is there. Okay, and then you can connect those. Right, and there's our inverse function. Okay, then asks, what is the equation of the inverse function? Well, here's our original function. So our inverse function is when you switch x and y. So then you switch x and y, and then solve for y. So you add 3, right, and then to undo the 1/2 y, you multiply by 2. So remember, you need to multiply to everything. So you get y equals 2x plus 6. Okay, and you'll see that here on our graph, right? 6 here is our y-intercept, and this is clearly a slope of 2, right? It goes up 2 over 1. So the graph of the lines have a line of symmetry. If so, what is the equation of that line? So actually, it does have a line of symmetry. Usually, most people are looking for, like, vertical or horizontal, right? It's not very obvious. You'll see more in the next lesson. But the line of symmetry is here. And I wish I had tracing paper. I'll probably get some. But it's the y equals x. Let me draw this in like a fun color here. And you notice, like, it folds over this. Like, I could fold my paper, like, along the line, right? And then this will land on top. So this is the line of symmetry. So line of symmetry, yes. The line symmetry has the equation y equals x. Yo, the one good thing about this video is I don't have to make 3 of them, right? Remember when I ever did classwork, I did it 3 times. Now I only have to do 1 time for you all folks. Okay, now we finished the front page. Now let's go to the back side. So 5-9 Antonio's function machine shown at right. What is a of 2? So a of 2, right, if the function is 3 to the x, then a of 2, basically, you plug 2 into here for x, so you have 3 squared, so a of 2 is 9. Now it says, if 81 come out, what was dropped in? So basically, 81 is equal to 3 to the x. What must x be? It kind of helps. Basically, 81 is 3 to the what? Let's kind of like figure that out here with this table. So if you have, so if x is 0, 3 to the 0, right, is 1. So obviously 0 wasn't dropped in. If x is 1, then 3 to the 1 is 3. And if x is 2, as we just did, right, then 3 squared is 9. And if x is 3, then if that's 3 cubed, that's 3 times 3 times 3, that's 27. Right, and if x is 4, then it's 3 times 3 times 3 times 3, I lost count. 3 times itself 4 times, right? Which is also this times 3, right? So it's 81, right? The pattern is like times 3 each time. So the answer to the question then is x is 4. So because 3 to the 4th is 81. Okay, so if an 8 came out, what was dropped in? So be accurate to 2 decimal places. Okay, so I said hint, use your graphing calculator. So I'll show you that here in your graphing calculator. So, who knows what's on here? Okay, look, that's from our last lesson, guys. Miss it already? Okay, so, if 8 came out, so basically it'll help if we graph this function. So we graph 3, and then you want to use this button here, 3 to the x. And basically we want our output to be 8. So we want our y to be 8. Now before we graph it, let's go look at the table, see if it matches this table up here. It does. Look, so here let's scroll down so it can make. Look, so here what I said, right? Here's 0, 1, right? That's on our table here. 1, 3, 2, 9, 3, 27, 4, 28. Obviously, you can tell, like, our answer is going to be in between 1 and 2, right? Because when it's 3 to the 1, it's 3, and 3 to the 2, it's 9, right? So when you're trying to figure out what x is, when it equals 8, it will be between, x will be between, that's ugly, whatever. X will be between 1 and 2. Again, because 3 to the 1 is 3 and 3 to 2 is 9, right? So it skips over 8. So now let's look at our graph. So go back to here, go press, let's press zoom 6 to get our standard graph. Okay, here's our exponential function. Shoop. Right, and then here, slowly but surely, is our y equals 8. So basically we want to know what y value, or what x value, right, is going to give 8. So we need to find this point of intersection. And like I said, it's going to have an x value between 1 and 2. So remember, to do that, you press second trace, right, and you pick intersect. You press enter, enter, and then you go over to guess where the intersect is, and you press enter. There it says intersection 1.89 y equals 8. So again, we could have guessed it was going to be closer to 2 because 3 to 1 is just 3, and 3 squared is 9, which is a lot closer to 9. So that's why x is 1.892. Right, because that's our x value of our intersection. Okay, now moving on. Solve the following equations if possible. Some of you can solve exactly, others approximately. So if a solution is not possible, explain how you know. So 1 to the x is 5. This is not possible because 1 to anything is always 1. Okay, next problem. 27 to the x is 81. Okay, well, these are basically there's exponential equations. You might not remember, it's been a while. Basically, let's square both of these sides first. So then you get 27 to the x equals 81 squared. Okay. Now, donate square 81. You don't really want to do that. Remember, the goal is to try to make the base of these exponents the smallest possible and the same. And then you can set their exponents equal to each other. So we know from the previous problem that 27 and 81, right, are both powers of 3, right? 27 is 3 cubed. right? 3 to the 3. And 81 is 3 to the 4th. And remember, when you have a power to a power, let's zoom in here, right? 3, that's 3 to the 3x equals 3, and then you multiply them, right? 3 to the 8th. So now they have the same base, so then you can set their exponents equal to each other. Because if you have 3 to something equals 3 to something, those somethings must equal each other. So 3x equals 8. So then x equals 8/3. Okay. 2 to the x equals 9. Right, you know all the powers of 2. Let's go over those. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 2 squared, which is 4, 2 to the 3 is 2 cubed, which is 8, right, 2 to the 4 is 16, right, 2 to the 5th is 32, right, they double each time, the powers, times 2. Right, so 2 to the x equals 9. Well, first of all, you might have been able to tell right away that, like, 9, this is not even, so that's definitely not a power of 2, right? So to find that x value, you know that's going to be some kind of not an integer, right? And you already can tell, right, here, it's going to be in between 2 and 3, right? Because 2 squared is 4 and 2, ooh, I was wrong. Cut that out. It's going to be between 3 and 4, right? Because 2 cubes 8, 2 4 is a 16, right? So it skips from 8 to 16. We want to be 9. So we know that it's going to be between 3 and 4, and it's going to be closer to 3 because 9 is closer to 8 than it is to 16. So let's use our calculator again to figure out what x should be. So same thing, you want to, this time though we want to do 2 to the x, and we want it to be 9. So we go to our graph, then that's our exponential function, that's 2 to the x, and then there's 9. So then again, we want to find this point of intersection. It's going to be something comma 9, and then we need to figure out what that x value is. And we've already said that's going to be closer to 3 than 4 because 9 is closer to 8 than it is to 16. So we're going to go second calc, and then press intersect, press enter, enter, and then move here. There we go. Our intersection is 3.169, right there. So, like I said, closer to 3 than is 4. So there's our answer. Okay, and then here, 25 x plus 1. So that's, you can do that to this one. These are powers of 5, right? This is 5 squared, and this is 5 cubed, right? Again, you make your table, right? 5 to the 0 is 5, 5 to, oh, nope. 5 to 0 is 1, 5 to 1 is 5, 5 squared is 25, 5 cubes is that times 5, which is 125, 5 to 4 is 625, right? So, 25 is 5 squared. So you have 5 squared. We'll zoom in here. 5 squared to the x plus 1. And then this is 5 cubed to the x. So 25 is 5 squared. 125 is 5 cubed. And then you want to multiply those. So that's 5 to the 2x plus 2. Make sure you distribute the 2. And then 5 to the 3x. And then, again, you set the exponents equal to each other. Because, yeah, 5 to something equals 5 to somethings. Those somethings must equal to each other. So, 2x plus 2 So you get, and then you just solve for x. So you subtract or 2x from both sides, and you get x equals 2. Okay, last equation. These are all powers of 2. Right. We make our table here. 2 to the 0 is 1. 2 to the 1 is 2. Oh, we already made our table. JK. Cut that out. There is our table there, right? There, if those 2 to the x, right? 8, right, is 2 cubed. 2 is already there, and then 4 is 2 squared. So we write this here. So that's 2 cubed to the x, to the 5th, and then that's 2 squared to the 4th. And then from there, you just use your properties of exponents. So that you have power with power, you multiply them, that's 2 to the 3x. Then that's 2 to the 8th. And then remember what you do when you have a product. You add the exponents. So that's 2 to the 3x equals 2 to the 13th. Then you just set your exponents equal to each other, and then solve for x. So then x equals 13 over 3. Okay, last problem, guys. You're almost there. Graph inequalities. Okay, so remember, right, our absolute value function in general, back in the day, right, this HK is our vertex. So for this first one, right, our vertex, right, essentially is, so it's the opposite of the inside, and then the same as that on the outside. Since there's no on the outside, our y value is 0. So for this function, right, it's the same thing as that. And so our vertex is 2, 0. So you want to plot that right here. And then our a value is 1, so you just have a slope of 1. And because this is underlined, we do make it solid. So make our v this. Hopefully you guys can't hear my boyfriend in the background outside when I play this video. Okay, so, and then it's going to be upwards because it's greater than, okay? And then the other one, right, y is less than 4 minus absolute value of x. It's kind of switched around, might look a little funky, but this really is negative x plus 4, which is the same thing as negative x plus 0 plus 4. So that's this one. So basically our a is negative 1, our h is 0, and our k is 4. So vertex for this one, right, is 0, 4. So you plot that here, 0, 4, and the negative 1, right, a slope of 1 but upside down. So okay, and then shaded down. So our intersection is this cute little rectangle right here. And so it says what the area is of the enclosed region. The area, right, is length times width because it's a rectangle. These are perpendicular because the way that slopes work, negative 1 and 1 are perpendicular slopes, right? And then so basically you need to figure out what these sides are. Okay, so let's see, like this side, right, we'll call the width, right? This if you want to basically draw a little slope triangle and figure out what they are using the Pythagorean theorem. So the slope triangle here, right, is 1. So let's say w squared equals 1 squared plus 1 squared. So w equals squared equals 1 plus 1. So w squared equals 2. So w equals root 2. Okay, and then this side right here, right, that's the length, right, and you draw a little slope triangle, right, then you can use the Pythagorean theorem also. So L squared equals 3 squared plus 3 squared, right, this is 3 and this is 3. A squared plus b squared equals the hypotenuse squared. And then that's 9 plus 9. L squared equals 18. So L squared equals root 18. And then if we simplify that, right, that's 9 times. That's, that's 3 root 2. Okay, so then we plug them in. So then that's 3 root 2 times root 2. Root 2 times root 2 is 2, so that's 3 times 2. So the area is 6. Okay, there we have it. Thanks for watching my homework questions video. Hope I got all your answers. If you didn't, just hit me up. Okay, bye!